The overall goal of this procedure is to train rats to increase the number and complexity of their ultrasonic vocalizations, or USVs. This is accomplished by first recording baseline vocalizations. The next step is to train for targeted vocalizations through positive reinforcement. After training, post-training vocalizations are recorded. The final step of the procedure is acoustic analysis and comparison of baseline versus post-training vocalizations. Ultimately, results can be obtained that show training increases the number and complexity of ultrasonic vocalizations through increases in acoustic parameters such as bandwidth, peak frequency, and duration.
This method can help answer key questions in the field of communication disorders, such as how vocal exercise modulates underlying neural mechanisms.
Though this method can provide insight into craniosensory motor deficits associated with Parkinson's disease and aging, it can also be applied to other disease models and conditions that use ultrasonic vocalizations as a behavioral index. Demonstrating the vocalization training will be Emerald Dahl and Jamie Shire, members of my laboratory.
To begin ultrasonic monitoring, load the Avisoft Recorder software. Select Permanent Unlimited for the trigger to allow for recordings to be started and stopped manually. Next, designate where the captured audio files will be saved in the base directory. The sampling rate must be at least 200,000 Hz to capture the highest vocalization frequency. Once these parameters are set, remove the top of the male's home cage and place it directly underneath the microphone. Next, identify a sexually receptive female rat in estrus by the presence of lordosis, ear wiggling, and rapid darting. Place the receptive female into the home cage of the subject male rat. When the male shows interest in the female by sniffing, chasing, or mounting her, remove the female and record the male's vocalizations for 1 to 2 minutes. Monitor the ultrasonic vocalizations visually by watching the real-time spectrogram. If the male does not vocalize immediately, briefly return the female rat to the male's home cage to stimulate vocalization. To begin, bring a single male rat into the training room. All other males should be kept in an adjoining room until their training session. The rat should have restricted access to water beforehand to facilitate the use of water as a reward during training. Set up the Avisoft Recorder as shown earlier. Next, position the home cage underneath the microphone. Once the male is in position, introduce a receptive female rat into the cage. Remove the female once the male has shown interest in her and monitor for target vocalizations. Initially, any 50 kHz frequency modulated call is rewarded. Present the reward by simultaneously clicking a pen and briefly presenting a water bottle or food treat. As training progresses, only increasingly complex strings of calls, such as strings of 5 or 10 calls in rapid succession, are reinforced. Continue training until 30 reinforcements have been given. This typically takes 5 to 10 minutes. To analyze the baseline and post-training recordings, first generate an archive of the original sound file and make edits on a working copy. To remove noise at frequencies below the ultrasonic vocalizations, use the batch mode of Avisoft SASLab Pro to high-pass filter all sound files at 25 kHz. To determine the noise threshold needed to use the automatic element detection feature of SASLab Pro, open a sound file and create a spectrogram. set the FFT length to 512 with a 75% frame size and a temporal overlap of 93.75%. Enable waveform editing so that noise erased from the spectrogram can be removed from the waveform. Set up the automatic parameter measurements as shown here. The three parameters to be measured are duration of element, peak frequency, and peak amplitude. In the Location of Measurements section, enable maximum amplitude and the minimum and maximum parameter of the entire element. Under Element Separation, select Automatic Single Threshold and Show Threshold. Find an area of the spectrogram where there are no calls or noises. This is the background noise. Set the threshold to just above the background noise by adjusting the black line in the power spectrum window above the spectrogram. The decibel level of the threshold set in the previous step can be found here. Set the Rejective peak amplitude is less than value to 1 decibel below the threshold. These two values should now be used for all sound files analyzed, assuming all recording settings were the same. To label the vocalizations, create a spectrogram using the automatic threshold set earlier and the same settings shown previously. Manually erase any noise that meets the following criteria. 1. That has been wrongly identified as a vocalization. 2. That is affecting the discrimination of the beginning and/or end of the vocalization. 3. That has been wrongly identified as the highest or lowest frequency in the vocalization, which are indicated by the upper and lower red lines respectively. In some cases, a vocalization cannot be separated from the surrounding noise, such as the sound of bedding during locomotion. This call cannot be accurately analyzed and should be erased. Once all vocalizations have been identified, permanently erase the deleted sections of the spectrogram from the sound file by selecting Remove Erase Spectrogram Sections from Waveform from the Tools drop-down menu. To create permanent labels in the sound file, open the Automatic Parameter Measurements Setup window and click the Edit button in the Element Separation section. Visually and orally review each labeled vocalization to determine its category and assign the appropriate label using the predefined text modules. The categories we use in our analysis are simple, frequency modulated, and harmonic. Close the spectrogram, save the sound file, and continue with the next sound file to be analyzed. After vocalizations have been identified in all the sound files, use the batch processing tool to automatically measure the acoustic parameters of all the files. In the batch processing dialog box, select Automatic Parameter Measurements from the drop-down menu. Select the Process all files in the selected folder checkbox, then click the Folder button and select the folder where the sound files are saved. Click Start and each file will be automatically analyzed according to the settings last used in the Automatic Parameter Measurement Setup dialog box. The measurements will be saved in a text file that can be defined using the DDE parameters/logfile setting command. This text file can then be imported into a program for statistical analysis. These graphs demonstrate that the number of vocalizations per session and the vocalization rate per minute both increase over a 6-week training period. Representative vocalizations of each of the 3 categories of 50 kHz vocalizations that we use are seen here. From left to right, they are simple, frequency modulated, and harmonic. In this example, frequency modulated vocalizations from the same rat are shown before induction of Parkinsonism, post-Parkinsonism induction, and after vocalization training. Compared to the baseline vocalization in panel A, the vocalization in the Parkinsonism condition in panel B shows a reduction in bandwidth, duration, and intensity. The post-training vocalization shown in panel C demonstrates how duration, intensity, bandwidth, and frequency modulation return to baseline levels after vocalization training.
After watching this video, you should have a good understanding of how to train, record, and analyze the ultrasonic vocalizations of rats.